Hello, welcome to Connect 2017 Day 3 training. My name is Adrian Stevens.
I'm Mark Smith.
And we're part of Xamarin University, and today we're going to tell you about building universal Windows applications using the UWP APIs to build Windows apps.
Perfect.
Excellent.
Yeah.
Let's talk just a little bit about Xamarin University before we kick it off.
Yeah, awesome. So Xamarin University is the place to come if you're trying to do any sort of mobile development with Microsoft tools. We've got extensive training and free content and videos and all sorts of stuff that you can use in order to enable yourself to build fantastic apps using Microsoft tools for mobile or for cloud attachments. So
Absolutely.
If you're going to be talking to the cloud, we've got content for you there too.
Excellent. We also have subscriber-based live classes. So these are classes you can take with live instructors online, and they are taught in 2 to 3 hour sessions. We've got I think over 70 courses now.
Yeah, I actually think it's closer to 80. But
Fantastic, and we learn all kinds of things. So cross-platform strategies, architectural patterns, enterprise strategies.
Right. Debugging, diagnosing performance issues.
Async await.
Right.
Multi-threading, multitasking applications.
Properly synchronizing multiple threads inside your mobile apps. All kinds of great stuff.
Absolutely.
And as part of that, we actually have certification offerings. So we have 2 different certification tracks, and you can actually get certified and even get cool swag like this Xamarin University monkey. So you can do that through either some of the free content, and then you can take an exam and get a professional level certification, or move into the live training, which is a subscription tier, and get a developer level certification.
Fantastic. And once you're certified, I think I want to head over to DevConnect.
Yeah, so DevConnect allows you to then promote your skills and be able to see who all is certified so that employers can go to that site and find somebody in their area that can help them build the app that they're trying to build.
Really fantastic. So great place to showcase your skills. Let people know what features, what skills you have. Show that you're certified, and then have local companies hire you and have you build amazing things.
Totally. And one last thing with Xamarin University that I think is really, really interesting. I think actually it's probably the coolest feature of the product. When you are a subscriber with Xamarin University, which by the way is really cheap, you can actually get office hours, which means you can interact directly with an expert Xamarin developer one-on-one. Talk about your app, talk about what you're trying to accomplish, ask your questions that are unique to your particular app. They can help you diagnose problems, help you design an architecture, or at least guide you in that. So they won't necessarily write code for you, but they will answer questions and things like that. We call them office hours. It's a great deal. I mean, I almost hesitate to say it's a steal for the price of a subscription for Xamarin University.
Oh no, I absolutely agree. Being able to talk to an expert, discuss the problems I'm having that are particular to my projects, to my applications, and get expert advice, expert guidance, invaluable. It's really amazing. Yeah.
So cool. So cool. All right. Well, we're actually here to talk about UWP development. So
let's rolling.
Move into it.
Absolutely. And actually, on the topic of getting help, you can actually ask questions during the session here as well. And we'll do our very best to answer these questions as we go. So please feel free to use that feature on the website. And let's talk about building UWP applications.
Let's talk about building UWP apps.
So really, the device landscape has changed quite a bit in recent years. And of course, technology always moves quickly. But it really feels these last couple of years, things have really just jumped forward. And we used to say, you're a Windows developer, you instantly think of desktop. Or maybe these days laptop. But being a Windows developer is really, it's so much more now. There's so many different devices, and there's so many different devices that run Windows, and that run Windows 10. So our traditional devices of laptops and desktops and tablets. Of course, there's mobile. But now we have things like, we have gaming, we've got Xbox.
Yeah.
That's running Windows 10. We've got emerging device categories like holographic, HoloLens.
Augmented reality. That's kind of a new category in that as well. Yeah.
Yeah. IoT, right? This is a huge industry, and again, these devices can run Windows 10. And of course, then there's team devices as well, things like Surface Hub, where they're meant for teams to collaborate on large scale devices.
Right. I think actually this might be a Surface Hub right here.
This might be actually. It's I see a pen over here. Absolutely, it is.
Yeah.
Pretty fantastic.
Wonder if they'll ship that to my house.
Yeah.
Probably not likely. Oh well.
But so now being a Windows developer means I've got to target all these different devices. And historically, this meant writing different applications for these devices. So this is where UWP comes in, and this is a platform, and it's a universal application architecture to target all things that run Windows and Windows 10. And so we can now write applications that can target the full scope of devices. using a common API. So really fantastic, really powerful. And it means that we're not rewriting our application every time we want to target a new form factor.
So let me make sure I understand. So what you're saying is with UWP, I have the ability to write an app, and I can run it on, say, my desktop.
Absolutely.
I can then run it on my Xbox, and I can run it on my HoloLens, and maybe even my mobile device if I have one.
Absolutely.
Is that what you're saying?
That is what I'm saying.
Even though those are dramatically different devices with different forms of user input and different sort of visualization kind of models, I have the ability to do that with UWP. That is really fantastic.
Yeah, and it really nods to the Windows model, and we're seeing this move to this common Windows core that's actually run the same kernel on the same core OS on all these devices, and so we're getting this nice common API pattern we can use to target all these devices.
Yeah, that's very cool.
Really fantastic. So hopefully you're excited about this. Let's talk just a little bit what we need to do to get up and running with Windows UWP development. So not surprisingly, we're going to use our favorite IDE, we're going to use Visual Studio.
Yeah, and to be specific, Visual Studio for Windows because we're targeting Windows.
Yeah, absolutely. And we'll be using Visual Studio 2017, which will be what I would recommend, absolutely. Now, what's really nice about UWP is we've got a range of languages to work with. So we can use our favorite .NET languages. So of course, we use C#, we can use VB.
Right.
Now we can also use things like C++ and JavaScript.
Right.
So again, we can leverage the skills that we have. We use our favorite languages to develop these applications that run on all these devices.
Yeah, and I think it's important to remember. I mean, one of the things about UWP is that the APIs themselves they're not managed APIs. They're actually in the operating system. I mean, you're really programming Windows 10.
Absolutely.
And that's why we can use C++ and JavaScript to target them because you're just hitting those operating system APIs. When you use C#, you're using the CLR and .NET to do the same thing. But we have this freedom of being able to use multiple languages to be able to
Which
do
is
that.
really fantastic. Again, we can use we use the strategy that we're comfortable with to make our applications.
Yeah, so if you're a JavaScript developer that does HTML, you can still build UWP apps that run on your HoloLens.
Absolutely.
Very
fantastic. And then when it comes to deploying or testing our applications, well, if we're running on Windows 10, which hopefully we are, we can test locally.
Yeah.
Because of course, this runs Windows 10 applications, not surprisingly. We also have emulators for certain device types. Pretty fantastic. One of the fun ones we'll show off in just a few minutes is the HoloLens.
Oh, very cool.
And then, of course, we can also connect to remote devices. So there are some device types, so things like gaming, like Xbox. We don't yet have emulators. IoT, same thing. So we can connect these remote devices. And that's even possible with Windows 10, with full-blown tablet or desktop devices. We can deploy remotely to those devices. So if you've got a test device with a feature set that's different than, say, maybe your desktop development environment, we can deploy and test on those as well.
Yeah.
So a lot of flexibility there.
Very nice.
All right, so we mentioned this already, but we're talking about the common API. I'm going just a little bit more detail here. So with UWP, we have what we call the Universal API. This is what you expect. This is that API surface that runs on all of these device types. So again, that's desktop, that's gaming, that's holographic. But we also have some APIs that are device type specific. So something like Xbox Live Storage. Well, that's something that makes sense on Xbox Live, but doesn't necessarily make sense on your Surface Hub, for example, or on IoT.
Right, or the ability to place a call. It doesn't make sense on my desktop necessarily because I don't have cellular connectivity on my
Absolutely,
desktop,
exactly. Yeah. So we do still have APIs that are specific to certain device types, but generally we're working this universal API, and we're going to see how to consume these. But what's amazing about UWP is that we can leverage these APIs that are device type specific in an application that targets more than just those devices. So I can integrate those calling features when I'm running on a phone.
Yeah.
I can integrate the Xbox Live specific features when it's executing on an Xbox, but still within an application that runs on these device types.
Yeah, so it's somehow segregating it at runtime
Absolutely.
in terms of the APIs. Yeah, very cool.
And we'll learn a little more about that as we go on. Okay, so our applications. So we'll talk just a little bit about what makes up a UWP application. And this should be familiar to anyone who's done Windows development. There's a lot of commonalities here. And really, I mean, a lot of this is migrated from previous Windows versions and those kind of application strategies. So we're going to start with the application class. And this is really the main entry point to your application. And then it's got some other classes that are used to, well, really deploy the UI. So something that dictates where the window frame is, really where our application is displayed on screen, and then the elements that make that up. And we'll go into detail these in just a moment. And the other thing I want to mention is the app manifest. And this is where our metadata goes. So really, these are kind of our big building blocks. And again, this should probably be familiar if you've come from previous Windows environments. So let's start with the application class. So this is our main entry point. This is what gets kicked off when our application launches. It's also responsible for lifecycle management. So it's going to get notified when our application changes between lifecycle states. So when an application when a user launches your application, I should say, when it goes to the background, this will get notified, and we can do our lifecycle management, possibly saving off data, restoring state. It's also where we're going to store our application-wide resources. So we might want to have common styles or resources that we're going to use in multiple places in our UI. Well, we can store that in our application class and then consume those from our pages, our different sections of our application. And it's also where those unhandled exceptions are going to go. So hopefully we don't have too many of those, but if anything falls through, well, we can pick that up in our application class.
So those are global exceptions. If you don't catch them, then the application class is the last chance resort.
Right. Yeah. That's our last chance, I guess, probably before we crash, unfortunately.
Yeah,
so
that's right.
We'll pick those up.
Yeah.
Now, the window class, we were actually talking about this just yesterday. So this is really what represents the user viewable area of your application. And so it does a few very important things and things that we're, again, really familiar with as Windows developers. So, it gives you that surface area, but it also gives you, it's what defines really the frame of your application. It gives that resizable control. It's, it's where your minimize and your close buttons go. And then it's going to host typically a frame. And so the frame is not required, but it's very common in our UWP applications, and it's really what's going to control the navigation within our application. So it's going to be our first piece of UI, and its job is to display other pieces of UI and allows it to go that forward and back navigation that's fairly common in these types of applications.
Because most apps probably have more than one page.
Exactly.
Right? But even a single page app would still have the frame. It just represents a standard piece of the visual adornment that's in there.
Absolutely.
I got it.
And which is a nice segue into our pages. And the page class is really, this is where we start actually displaying our UI. It's where we display our controls, our visualizations. And so the frame class is going to host one or more pages and navigate between those. And really, so this is again, should be very familiar, this very common structure. And also, I want to talk just a little bit about how we build the pages. And the pages are typically built, well, in XAML with our UI, and they're comprised of two files. So we're going to have the XAML file, where we'll do our UI definition, and then we'll have our associated code behind file, where our behavior might go. Now, before we jump to a demo, I just want to talk about this app manifest as well. So this is where our metadata goes. So this does several important things. So this is really what identifies the application. So, and most importantly, this is where you identify your application when, say, deploying to the store. When you're publishing your application, it's going to store your visual assets. So, so that might be things like, I guess, like
your tiles.
Our tiles, like
the launch tile and things like that. Yeah,
absolutely. We also define our capabilities here. So this is where we decide. We're letting the system know what features we need. So are we connecting to the internet? Are we using Bluetooth? Those types of things.
We're using the camera.
Absolutely. Yeah. As well, we also have our declarations here as well. So that would be, I'm trying to remember exactly what the difference is. That is the, pardon me. So just declaring, again, the features that we need within our UB applications. Perfect. So let's do a demo. Let's build a new application.
I think as well, the application manifest is signed too, right? There's a certificate that signs it, so it uniquely represents the app.
Yeah, absolutely. When it comes to publishing.
Yeah, that's right. Got it. Cool. Well, let's see it.
Perfect. Let's jump over to Visual Studio. Let's make a brand new application. So to build UWP applications, we'll have to have the UWP workload installed with Visual Studio, and that should be installed by default.
Which is super easy to do with the new Visual Studio installer.
Absolutely.
It's just a button, you click it, and it installs all the pieces you need for UWP, or at least the latest SDK bits.
Yes.
Yeah.
And so we're going to go File, New, and we'll make a new project. And we see under Visual C#, I've got Windows Universal. But as we talked about, we can use other languages as well. And so if I do a quick search here, let's just do Windows Universal. Notice here, we've actually got a number of other languages. So we've got JavaScript and Visual Basic. If I scroll down, you actually notice that C++, we have the option to install the tool for C++.
Sure.
So that's not necessarily installed by default, but it's really easy to bring that in. And this is part of the team trying to streamline the installation process, so trying to reduce the footprint by enabling the languages that people are most commonly going to use, but still having it very easy to bring in these features if you so decide to use C++ later on.
Right, so it's a different workload, but you could have added it with the installer.
I absolutely could check that off in the installer. You'll notice here I actually have an extra one here, a holographic. I've installed the SDK for the HoloLens.
Very cool.
And this is, it's just DirectX. So it's still a UP application, but it's got some hardware acceleration, which is, very common when making our holographic applications. So I'll make a new blank app. And I make a kind of very hello world style app. I'm going to make a tip calculator. Let's just hit OK. We'll call this my tip calc. Now, this is interesting. So we make a new application. We get to decide which versions of Windows we're going to target. And we have both a target version and a minimum version. And this is going to really define the features, so really the APIs we're able to consume in our application, and also control which versions of Windows that we're compatible with. So generally, we try and choose a lower version for minimum, but if we have features that we absolutely need that came out in later versions of Windows, we can up that minimum version. I'm going to leave the defaults here for now, and we'll talk a little bit more about this as we go on to the day here. And so we'll spin up our new application. And let's take a look at what's created. And I'm going to start with the app manifest. So notice there's a nice GUI editor here. So we get our display name, our entry point. So, and again, all those visual assets you mentioned, so our tiles, here are capabilities as well. So let's now take a look at the application class. So this is our main entry point. And if we open up the XAML, you notice there's not a whole lot in here just yet. But this is where we could say add application-wide resources. So we could say define styles for controls or visual elements and then consume them in other parts. But by default, it is blank. And where the action is in the XAML.cs. And so let's show you a couple of quick things. So notice in the on launch, this is our life cycle. Let's just open this up so it's a bit easier to see. So on launch is called when our application is launched normally by a user. And a couple of quick things to point out. So you notice here we are creating, there's our frame. And then if we scroll down just a little bit further, we should see it creating a page and adding it to as the root frame of our frame. So this is going to be the first piece of UI that's displayed when our application is launched. In this case, we're creating a main page. And if we look at our solution here, we see the main page has been created by default. And this is just a page in our application. So here's our XAML. And of course, we have our associated XAML.cs, or our code behind.
Right.
And also,
which is a pretty standard pattern. I mean, almost every Microsoft UI technology in the last 20 years has used a code behind model where you have some sort of design file and then a code behind file.
Absolutely. So you're migrating from something like Silverlight or WPF. You're going to be very comfortable.
Or even
here.
Windows Forms or ASP.NET Web Forms, or even going further back. I mean, if you look at MFC, it often had some sort of dialog representation and then a form representation.
Right. Absolutely. So let's play a little bit with the. Let's build a basic UI here. Now, what I've got up is designer, and so this is showing. If you look at the bottom here, this is the XAML. So this is the language we use to define our UI, and then there's a visual representation of the design of our UI above here. Now,
which is looking suspiciously blank.
It's looking very, very blank. So I'm going to do a couple quick things here first. So we do have a design surface, and this is basically going to do a representation of our UI for each particular device. So we've got a Surface Book with a very, very high-res screen. I'm just going to change this to a lower-res device, just a little bit easier for us to see what's going on here. And let's give this a better zoom. Now, if you look at our XAML, we'll see that it's created a grid for us by default.
Okay.
Pretty nice. And we can go and we can even do things like we can add rows and columns visually, really nice and easy. And this is actually a feature that Mark was showing me earlier in the week. I tend to do a lot of this by hand. I was like, oh, Designer's gotten really, really good.
Yeah, Blend is the bomb.
Yeah,
if you don't use Blend for your UI, you should. It's awesome.
Yeah, and we've got a lot of fine-grained control here. So by default, these are set up as ratios to one another. So you can see we've got some numerical values here. So this is going to be the ratio of width of this column to the next one. And we can, of course, just jump up here and we can edit these fairly easily as well. For simplicity, I'm going to use, there we go. say 100 instead of 115. We see it resizes. But I'm actually going to change the view type here, or the layout type. And I use the stack panel, which is a really nice, simple. It's a really powerful layout panel that we can use to arrange our UI either horizontally or vertically. So let's just change this to stack panel. And notice, so I did it on the designer, but I've changed it in the XAML here already. And now
so the designer and the XAML are connected.
Yeah, they are connected. So I make changes in the designer, it's going to be reflected in XAML, and vice versa. So let's bring in some visual elements. So I'm going to click on Toolbox. Let's just pin this. And here we see all the controls, all the visual elements we can bring into our design surface.
That's a lot of stuff.
Pretty fantastic. And so again, if you've done this on other platforms or using other XAML-based tools, you'll feel right at home. And if you're just learning this for the first time, it's a really great way to explore really what's available in the control set. So let's bring in something that will just store some text. We'll bring in a text block. And then, so a text block is really used to display static text. So it's just a textual representation. And if I want to do some editing text, I'm going to bring in a text box. That's something that the user is able to, to change the input. So I'll bring that in. And so I'm going to build a tip calculator. So I want to have a little bit of guidance to the user. Then I want to have them be able to, add a bill amount.
Sure.
And then we'll add one more text block, which will actually show our final tip amount. And so let's do just a...
So no button?
No, we can actually drive it all from the text box.
Okay.
We could add a button.
No, that's okay.
All right.
Yeah. This is your tip calculator.
This is my tip calculator.
However you want to use it.
Perfect. So let's just do just a little bit of a massaging here. So we notice that everything's crammed up in the upper left-hand corner. So I'm going to just make some adjustments here. And so I've got the stack panel selected. So I've clicked on our layout here. You can notice that in the XAML here, stack panel is selected. And if I go to properties, you see we get all the properties for the stack panel. Now, just for simplicity and make it a little more responsive, I'm going to have the stack panel centered in our screen.
Okay.
Let's go to layout.
I see your opening layout.
Yep. Open layout, and we see you've got width, height. And then here's horizontal alignment and vertical alignment. It's a little bit squished off here. There we go. And let's just put this centered. And we see right away, so we're editing the properties. And notice that we've changed our visual representation. And we also, if you look at the XAML, you can see here it's added in the horizontal alignment and vertical alignment. So again, we actually now have 3 ways to interact with our visual elements here. Let's next select our text block. Looks like I've duplicated. Let me take one of those out. Let's grab. Let me zoom in here, make this a little bit easier. There we go. So now we see we have the properties for our text box, our text block, I should say. And let's get a few things here. So I just want to change the default text here. So let's scroll down. There it is. So the default text for the text block is text block. Let's get something a little bit more meaningful. Let's say enter bill amount. And again, we see that reflected in our design surface. Let's grab our entry. So we're going to use this one to actually have the user add text to enter the bill amount. So I'm going to clear out the default text. Now, I also want to interact with this one. So I can use a couple of ways. I could give it a name property, and that will allow me to interact with this control in the code behind. Or I can also wire up an event. And we have the event handlers, and again, it's all built to the properties. So I click on the event handlers. That's a little lightning bolt. And I can come down here. And I'm going to make this, we can do this a number of different ways, but I'm going to do it. I'm going to update our tip amount every time the user changes the text in this text box. So I'm going to the bottom, and I'm going to look for text change. So the text change event will be raised every time the text is changed. So I'm going to go, let's just go bill amount text changed. I'm going to push enter. And notice this now switched to our code behind. So we're in main page.daml.cs. This has actually created a method. And this method will be raised every time the text has been changed. If we go back to our XAML, again, notice.
Yep, it's added in. So do me one favor, select all 3 of those. Can you do that in the designer?
I think so.
Can you just select them?
Yep.
Yep, and go, oh, it doesn't let you select multiple types. That's too bad. I was going to say maybe you could change the margin to put some spacing around those. Those are all sort of crammed up.
They are a little bit crammed up, yeah.
Oh, you're on events, that's why. Try it again.
All right,
switch over to properties and see if it So you switch back to
Back to
properties. There you
properties.
go. Yeah, go to margin and just change those, like put a 10 margin all the way around.
Excellent.
There you go. And it should adjust all of them.
Fantastic.
Yeah, so then we'll have a little bit, just looks a little bit nicer.
A little more space, I like that.
Yeah.
And then last but not least, let's just zip through here. I'm going to delete the default text on this text block. Again, so I can do it in the editor. And I'm going to give this guy a name as well. So let's just call this tip amount.
Okay. And that's going to create a field in your code behind that you'll then be able to interact with that associated with that specific visual element.
Exactly. So let's go back to our code behind. So this is our associated code behind, and we're going to go to our bill amount text change method. And so what we want to do is we want to read in the user entered bill amount, and then we're going to do a quick calculation and then apply it to that text box. So let's make a quick double. So just a little standard C# now. So I'll go double. Let's call this bill. We'll just default to 0. And then we're going to do so we're going to read in the text from the entry, from the text box. So actually, I'm going to do it this way. I'm going to add a name to our text box as well.
Instead of using sender.
Instead of using sender, I could your preference.
You can put a name on it.
Let's put a name on it. So I'm going to call this.
I think it actually sends it to you too. I think your event args has a text. There's a text changed. Gives you the new value.
Oh yeah, I suppose it does, doesn't it? There's a number of ways we can do this.
Yes.
I'll call this bill amount. We'll do it like this. Excellent. I like this because it makes it very concrete. So I'm going to go back.
As with most programming things, we can solve this problem using a hammer or a screwdriver.
That's true. We do have the text change event args as well. Of course we do, yes.
Yes.
So, okay, well, we'll do both ways. We'll go fast.
No, it's fine. Just do it however you want.
So double try parse. So I want to get the string out of our control. So we just give it a name of bill amount. And if we go bill amount, and bill amount has conveniently a text property. And this is going to be the representation of the text that's been entered into that control. And then for double try parse, I'm just going to get the value back out. So I'm going to go out bill. Now let's just wrap this in an if statement. So if this is successful, we can do a quick calculation. So we'll go bar tip equals bill times 0.15. And then we're going to assign this to the text property of our tip amount. So we'll go tip amount. That's our text block. Also has text property. And let's just assign this. And we'll use the C, and this is going to format it as currency.
Great.
Great. Let's go ahead and run this.
Is 15% like the standard in Canada?
I think that's a very standard tip. Should I bump it up? Is it a
no,
little bit higher? Yeah.
It depends on the service, I suppose, right?
Absolutely. And here we go. We see we enter in our amount, and we see that our tip has now been displayed.
$15. Perfect. That is 15% of 100.
There we go.
So, unlike other calculators that we've seen recently on mobile devices, that one works.
This one does in fact work.
Very nice.
Excellent. I'm going to move on to our next demo, or our next section. We've got a lot of content to cover here. So that was a really basic introduction to UI development, and there's a lot to learn there. What's great about UBP is there's a ton of amazing content out there. Microsoft Virtual Academy, Channel 9. There's lots and lots of great content to learn how to build responsive UIs to UWP. And I'm going to show you some other resources at the end of our session today. But I want to talk about some other ways to make our applications adaptive. And this is where I think UWP is really interesting. So again, we talked about this. It's very easy. Well, it's hard to say it's easy, but it's very common to make our applications UI adaptive, right?
And I think that's what most people think of when you say the word adaptive. You immediately think, well, that means that it's going to scale properly when I take it from big screen to little screen and vice versa.
Absolutely.
Or when I rotate it from portrait to landscape, it's going to affect, it's going to automatically change it.
Absolutely.
That's what I think of when you say the word adaptive.
And which is going to be
responsive.
Which is going to be very important when targeting all these different device types. But there's other ways we make our applications adaptive. Let's talk about platform adaptive. So we talk about Windows now running on all these different device types, different platforms. So we can actually change the feature set or the APIs we call based on the executing device type, and we can make decisions at runtime. And then the other thing we can do is make our application version adaptive. And this is something that's maybe a little bit less common coming from other platforms. We're actually able to execute specific APIs based on the version of Windows running on that device. And what this allows us to do is write applications that take advantage of the latest and greatest APIs while still maintaining backwards compatibility with older versions. So yeah, let's talk a little bit about platform adaptive. We kind of jumped into this, and it's really just adapting the behavior and the code based on the executing platform. And so a nice example here is, maybe we're making an expense application. So, and we want to scan in documents, we want to scan in, expenses. On a desktop, we might use a flatbed scanner. Attach a piece of hardware and leverage those scanning APIs. Where if we're on a mobile device, well, we're probably not attaching a scanner.
I can just take a picture.
Exactly. So we'll use the camera on the mobile device. So again, making it platform adaptive, we're still maintaining the behavior of the application, but we're making the application behave reasonably on that executing platform.
And to be clear, it's the same binary running on both.
Absolutely. We're going to use the exact same binary on both on both platforms, but we're going to execute different code based on the device type.
Very cool.
Now, to understand how this works, we need to understand a little bit about how UWP APIs work. And the APIs are partitioned into functional areas that we call contracts. And so you see some examples here. We've got Universal. We've got some APIs around Xbox Live Storage. So let's look at one example of a calls phone. So the API contract is a collection of APIs. So it's going to have a number of methods. It might have properties, events, all the things that encapsulate an API. And they're grouped into a contract. And so here again, calls phone, excellent example. And this is not the full scope of calls phone, but you see it's a collection of related APIs. And we call these an API contract. And so it's really a chunking of the API. Now there's one special contract I want to mention. This is the Universal API contract. And this is the full scope of APIs that are available on every device. And it's quite interesting that the API contract, it's actually one contract for all those APIs that are common across all the device types. Now, this might seem like a little bit of a superficial grouping, but it actually turns out to be very important when we're talking about the language of UWP. And what you're going to notice is the majority of the APIs you're going to use in UWP development actually is encapsulated in the Universal API contract. The last active it was over 85%. So
wow, that's significant.
It's actually it really is significant, and so
these are APIs that I can use no matter what kind of device it is.
Absolutely,
so it covers. It's kind of like .NET Standard, right? It's a way of identifying the specific APIs available across the board.
Absolutely, it's actually really excited about UWP. Is it means that for the most part, we do a lot of work in this universal contract, without worrying about the specifics for the other devices. Now, we've danced around this quite a bit. We talked about different device types, we use different languages, and there's a specific language UP uses that's called device family. And we have a number of device families defined. So we have things like, we have desktop, which of course is traditional desktops, or even things like your laptops, or even tablets that are running the full desktop Windows environment. We've got mobile, of course, our mobile phones, our Windows mobile devices, Xbox, our Xbox One, our S, our new Xbox One X.
Right.
Of course, holographic, like our HoloLens and IoT as well. And
I see you have Surface Studio there. That's Rob's favorite.
Yes, yeah.
So wants a Surface Studio.
It's an aspirational device.
Yes, that's right.
I think it's
they are beautiful.
It is many people's favorite devices, I think.
They are beautiful.
And so these are device families, and each device family has an identifier string. And it turns out the string is actually fairly important when it comes to declaring what device types, which device families we want to support with our application. And you'll notice these device strings are actually, the identifier strings are fairly well thought out. They're very easy. Windows dot, and for the most part, it's just the device family name. So Windows dot universal, dot desktop, and dot mobile. Now, before I move on, I should talk about this universal device family. So this is actually a virtual device family. So it doesn't really, it's not a specific type of device, but it's actually all devices. And so there's a family that's defined, and it basically means if you're in the universal family, well, it's basically all Windows 10 devices are in this universal family. And it turns out this is actually important in terms of declaring declarations.
Hence the name universal.
Hence the name universal.
So does that mean that I can use these device families to then restrict my app and say, you know what, I only want this to run on this set of device families? Can
Absolutely.
I do that? Okay.
And that's exactly what we use those strings for. So I want to talk about how these device families play into the API contracts. So for example, a mobile device has access to the universal API contract, and it also has access to contracts that are specific to the mobile device. And so everyone has access to the universal contracts, but then there are some contracts that are device family specific. So now when it comes to targeting these devices, We're going to put this in our app manifest, our package.app manifest, and we can decide which device families we want to support in our application. So you might be thinking, hey, we should always target all of them, but some
That means I have to buy all of them.
You have to buy all of them, and we saw things like IoT headless,
yes,
which doesn't have a UI, requires some different coding strategies, and so we might be adding more functionality down the road and incorporating more devices, or maybe we only want to target desktop. We want to use desktop features, so we can restrict execution on certain device families.
So would you give the advice to just say, put the target device family to be the devices you want to support?
Absolutely.
Like things that you're willing to commit to and say, if I get a bug, I will actually fix it.
The things that you're testing against and the things you're designing for, absolutely. Yes. And this is probably a really powerful thing to remember as well, is that we don't have to support everything. We have the ability to, but we don't have to support all the platforms in our applications.
Yes, which is probably good advice, just because you can.
It's because again, doesn't mean you should.
Yes.
So we see here we're targeting Windows Desktop and Windows Holographic, and those IDs for our device families. Of course, we can. This is where that virtual device time comes in. We can say, I want to target the Windows Universal Device family.
Which means everybody.
And that means everybody.
Yeah.
And that's why this exists as a device family. It lets us just target everyone.
Now, it seems like that would be a little dangerous, because I could do that just by specifying every single one of those strings. But if Microsoft in the future added a new string to represent a new device family, say, for instance, we now have Windows Auto, and it's going to have its own device family. By specifying Windows Universal, it would mean my app would automatically be allowed on Windows Auto? Is
Absolutely.
Correct?
So, I mean, my recommendation for production applications would be to always be explicit.
Yes. Okay.
So,
fair enough.
Which I think you agree with as well.
Yes, I think so. I was just trying to verify that was sort of what was being. It seems like this is a little dangerous to say open-ended. Yeah.
I think maybe the advice here is this is a great one for testing.
Yeah, that's right.
And then, so we've talked about these contracts that are platform specific or device family specific. And the way we bring those in is we bring in what we call extension SDKs. And so there are a number of extension SDKs that are specific to certain device families. Now, not every device family has an extension SDK, but desktop does, mobile does, and those brings in those APIs that are specific to those device families. Now, there's a lot of terms going on here, and there's a lot of we're talking about contracts and extension SDKs and device families, and so it can get, I'll be honest, a little bit confusing when you're trying to dissect, well, what can I use where? And the great thing is the documentation is really powerful here. And so when you look up these API contracts, you're going to see that it's very clear. So we've got device family here, so it's going to say exactly which device family is supported. In this case, we've got desktop for our image scanner. And then here's the actual API contract that it resides in. So this is the API, the image scanner class, this type. And it's defined in this API contract.
And that's the string that represents the API contract?
So that is the string that represents the API contract, but it's also the encapsulation of these APIs.
Okay.
And let's jump over to demo and have a look here. So I'm going to show you quickly how we can respond to different device types, and you can do this by actually showing you which APIs we have available on our platforms.
Great.
So let's make a new.
So is this where you're going to pull in HoloLens? I've been waiting for HoloLens.
HoloLens? I think we're going to pull in HoloLens, actually. Let's do that. So I make a new project, and let's just call this, let's just go, we'll call this contracts. And again, we'll choose our versions.
Yeah, and the interesting thing about that versions dialog is it really represents the SDK that you're targeting. And each time Microsoft updates Windows 10, they often have new versions of the SDK that are there. And so it tells you what's the minimum version of Windows that your application is capable of running on, and then what's the API set that you're targeting is really what you're answering.
And actually, I'm glad you brought that up. So I'm going to pull the documentation here. I want to show you, now that we've done into this a little bit, here we go. So if we go to docs.microsoft.com, we can actually see all of these different API contracts. And as you notice, we'll scroll through here. And so I'm looking at the Universal, and I'm going to go to the bottom. And so notice that Universal, so for our launch of Windows for 10.2.40, notice that we have 3 contracts defined in the Universal device type.
And that was it?
That was it.
That was the Universal contract.
Now, granted, so these are contracts, so there might be a lot of APIs.
Yeah, and Windows Foundation has a lot of stuff in it.
Yeah, sure. So there is a big API surface here. So it's not that there's only 3 APIs.
Yeah.
But notice that with each version of Windows, what we're seeing is we're seeing more and more contracts being moved to Universal.
And a lot of these contracts were defined in extension SDKs at one point in time, but they've moved out of those so that they were specifically restricted to certain device families, but now they've moved into the core universal contract so that they're just available across the board.
Absolutely. I'm going to show you an example of that. So if we go to the IoT extension SDK, we're scroll to the bottom here, and notice, so only 2 contracts, but notice that we have Windows devices low-level contract, and then system management contract. And we'll see the next release. These were iterated, so we got a newer version, but it's the same contracts. And notice what happened in 14.393. We're down to 1 contract. So the question, of course, is where did device level contract go? And exactly as you said, it was moved into universal. And if we go to 14.393, there it is. So that contract that was specific to IoT is now moving to universal. And so we're seeing this trend of more and more APIs moving to universal. And this is really fantastic because it means that although we need to be aware of where these partitions are and what's specific to what device type, which device family, more and more to be in the universal, and we'll be relying on these extension SDKs less and less.
And so if I'm targeting an older version than that of Windows, and so I include the extension SDK for the IoT piece, and I use one of those APIs, if I run it on a newer version, it will use the one from the universal contract.
Absolutely. It'll use the newest one available. Well, it depends on what you specify. But generally speaking, the out-of-box experience is it will use the newest one available. Yeah. Absolutely. All right. Let's build this one quickly here. So contracts, let's make a, so again, it's a new UP application. I'm just going to build a really quick UI, and I'm going to do this.
Use YAML.
Use YAML. We'll use YAML. So actually, I'm going to pull in a file here. So what I've got is a quick little factory class which lists the available API contracts just as strings. And so notice we go to static class with the static method called get API contracts. And all we're doing is returning an array of strings. Okay. So really basic, but just a little bit of pre-cooked logic here to get the API contracts out. And what I want to do is I want to show you how we can detect which contracts are available on your executing device and then potentially branch our code depending on that.
Right, so this would be runtime detection because, again, we're trying to build a universal app that runs on all these, but we recognize that sometimes on this device I only have access to these
Absolutely.
specific sets.
So this is runtime. Absolutely. Yeah. So we'll go back to our design surface. I'm going to change this over quickly. All right, and so I'm going to bring in, we'll leave our grid. Let's just bring in a text block we saw earlier into our surface. And I'm also going to bring in a list view. And interesting, I'm just going to clean these up a little bit. I'm going to take out to the margin. And put that vertical alignment. We just get rid of most of this. Perfect. And so previously we assigned names to these, but I'm going to use binding this time to pull in data.
Okay.
And so let's maybe bring that in first. So I'm going to switch back to our code behind of our main page, the .mlcs, and let's set up something to bind to. So I've got a list view. So what type of collection would I use for a list view?
I suppose any type of collection that you want.
Absolutely. So what if I want to update the collection at runtime?
Well, then it's going to have to be something that reports change notifications to the control that is representing visually that collection.
Perfect. So I think I'll use, in this case, I'm going to create a observable collection. And what I want to do is create a collection that's going to display the list of available API contracts on the executing device. So observable collection. I'm just going to display strings. And we'll just call this the contracts. And we'll instantiate that. And I believe we have to bring in, there it is.
Yeah, you need the namespace.
Collections object model, perfect. Excellent. And so we'll use this collection as our data contract, our data context. And so now we can bind to this, and I know we're showing another feature. So for those of you familiar with binding, this should be very comfortable. And if you want to learn more about data binding, both Xamarin University and Microsoft Virtual Academy have great content on this.
Yeah.
But then we have our observable collection as our data context. We can go back to our XAML, and so with our text block, I'm going to actually just show the count, so the number of contracts available.
Okay.
And so this is nice and easy. So
you say count, binding count.
Binding count.
Yeah. Nice. And then for the item source, for the list view, you just want to use the collection itself.
And it says item source and binding.
Yep.
So nice and easy. Excellent.
So you don't have to specify any property there because you're just binding right to the collection.
Exactly.
Yep. Makes sense.
Thank you. I always appreciate when it's validated. All right. And then what I'm going to do is when we're navigating to this page, I'm going to update our available contracts collection, and hopefully we'll display the available contracts on the device. So let's get the full list of contracts from our API contracts factory. So again, an array of strings. So we can call get API contracts. And also we just need to keep moving for time here. So go of our all contracts. And then let's just do iterate over the collection. Did I make a type? That's odd.
I think it's not. No, go back.
Oh, I missed the class name.
Yeah, it's the class name. You missed the type.
Yeah. API contracts factory dot. There we go.
There it
Perfect. For each of our contract and all contracts. Now, the way we can detect which contract is available on the etching device is to use a class called API information.
Okay.
And again, let's bring the type, bring the namespace. That's Windows Foundation metadata. And this has a number of interesting helper methods on here. The one I'm going to use is API contract present. And the parameters passed in are the contract name and then also the major version. And so I can now go through and pull in every contract. So we're going to iterate over the entire collection. And I'm just going to ask for version 1 for now. I need to close that off. Let's go up this as an if. And so if the API contract is present,
then you're just going to add it
to our collection. So let's just do this quickly here.
This looks like a good spot for a little link.
Yes, yeah. So we could go the quick way as well. Perfect.
All right, and contract has a toString. Oh, no, it is a string.
It is a string, so nice and simple.
Sure.
So we can run this. Let's run this on a local machine.
You clear out your collection first?
I didn't. We're a single page application. So, but you're right. We could clear it before.
True.
There you go. And so here we go. So
there it is.
Not the prettiest API or UI, but you can see there. So we've got 62 API contracts. Now, what's interesting here is we haven't actually brought in the extension SDK for desktop, but it is showing what's available.
Yeah, that is interesting.
Yeah.
Even though we don't have that extension SDK, it's still showing those APIs.
It's still showing that they're there. So we still need to bring the extension SDK to actually execute these APIs, but it is telling us these APIs are available to us.
Because they're available at runtime. So we're asking at runtime, metadata-wise, is that API available? But we wouldn't actually be able to program against it because we don't have like the corresponding assembly reference or whatever you want.
Exactly.
Think of it as, or header file or whatever.
Now, Mark asked earlier about a quick HoloLens demo. So I'm going to show you, I've installed the HoloLens emulator, which I'm just going to hit the drop down. And so this is a separate install, but it's freely available, of course. And I'm going to run this.
And this HoloLens emulator really is an emulator. It's running on Hyper-V.
Yes.
So it's emulating the entire HoloLens experience. In fact, it even looks like a pair of goggles, which is kind of cool. And it's just going to take that app, we're going to deploy it into that, and it's going to run it and give us the same kind of experience, but now with a HoloLens.
Absolutely, and it really runs as a virtual machine. Now, so let this spin up. It's starting. Now, something I want you to notice here is, if you notice the HoloLens emulator, if you see it in the background, it's a little bit grayed out, but you see it actually shows the Windows version number, and so it's not actually running the latest version of Windows.
Oh, interesting.
And so this is going to adjust the contracts that are available. So while this is starting up, we switch over. So we expect if we had a fully updated device that we'd have access to all of the universal SDK contracts.
Sure.
And if you notice here, we show the device family specific contracts, and there isn't currently an extension SDK for HoloLens. So there's no additional API contracts for HoloLens. But yes, I think there's 17 or 18 here. But of course, we're not running the latest version. We're not running 16.299. We're running 1400. So we're actually have a smaller selection of contracts available on this emulator. Now, let's see how are we doing here.
Oh, it's starting up. Just takes it a second.
Excellent.
You got to give it a second. There it is.
And so a lot of fun, actually. So here is our application running in our HoloLens simulator, which is really a lot of fun as well. And notice we actually have 12 API contracts available. And again, that's defined by the OS version installed on this device. and the fact that it only consumes the universal contracts. So,
Right, and we're not displaying any of the universal ones. We're just displaying the ones that are unique to the device family.
No, so these are actually the universal API contracts.
Oh, okay.
So these are actually only the universal contracts.
I see.
And these are only the universal contracts that are available on Windows. It was 14,
Whatever,
393.
yeah,
Exactly. We can run this on mobile as well and see a different selection. I think we're running low on time, so we'll probably wrap things up here. But before I jump out, I just want to make it very clear here. So we can use this API information class and check the API contract present. And this is how we branch. This is how we can decide what's available and then execute code based on that API.
Right, so I would use a similar if condition here with a runtime statement to say, do I have this contract?
Yeah.
Yes, then I can execute this code.
And what's really powerful here is even if the contract isn't present, the API surface is there. It'll fail at runtime if it's not available on that device.
Right.
But we don't have to, say, use compiler directives or make separate builds.
Right, because it's not statically linked. Right. Yeah.
All right, I think we should probably wrap things up. So we do have some resources here. So the great thing about UWP and Windows, there's a ton of fantastic content out there. So one thing I didn't have time to show you today, but I highly recommend you check out is the UWP experiences. So we didn't touch much on UI today. It's because there's so many great applications, sample apps out there. A ton of them here, UWP experiences, really easy to find. You see some really fun things about branching your UI between, say, desktop and Xbox.
Okay.
So doing things like respecting the screen padding in the Xbox, even doing things like adjusting your colors to be TV safe. So really great examples there. Of course, at Xamarin University, we do have a course on UWP. It goes a little deeper than this. Microsoft Virtual Academy, tons of great UWP content there. And of course, keep watching Channel 9. There's a lot more to come.
Yeah, that's right. Awesome.
If you have any questions, feel free to contact us on Twitter at XAMU. And thank you so much.